Hello everybody, I am Mrs. Prof.S.M.Shaikh, Assistant Professor in Electrical Engineering Department of AISSMS IOIT. In this video, I shall brief you about distribution system, which is a part of the first unit of the subject Electrical Installation, Maintenance and Testing for the third year electrical engineering students. So let's begin with what is a distribution system. So a distribution system is that part of the power system which distributes electric power for local use. So a distribution system is the electrical system between the substation fed by the transmission system and the consumer meters. So if you see in the figure 12.1 which is shown over here, there's a substation over here, right? There's a substation over here and it has the substation is over here and there are feeders, three feeders which are going to points A, C and D. Followed by, this is the distributor AB, BC, CD and DA are all distributors which are tapped at different points known as the service mains. So these arrows which are shown here are nothing but the service mains. So let us see what exactly are these three different parts. Yes, so in this figure we'll see what is a feeder. So a feeder is a conductor which connects the substation for localized generating station to the area where the power is to be distributed. Generally, no tappings are taken from the feeder so that current in it remains the same throughout. The main consideration in the design of a feeder is its current carrying capacity. Okay, because there are no tappings taken from the feeder, so the current carrying capacity of it remains the same, and therefore that is the main consideration while designing of a feeder. Now we come to the second part, which is the distributor. Like I told you that AB, BC, CD and DA, these are the different distributors in this figure 12.1. So this distributors, the current through the distributor is not constant because as you can see there are tappings taken at various places along its length. Therefore, while designing a distributor, voltage drop along its length is the main consideration since the statutory limit of voltage variation is plus minus 6% of the rated value at the consumer's terminals. The last point, that is the service mains, is that part of the cable which connects the distributor to the consumer terminals. Okay, so that part of the cable which from the distributor comes to your main energy meter, the energy meter at the main gate or main entrance of your if it's a residential one, then at your residence, or if it's a commercial one, then at the commercial entrance. So wherever your main meter is there, electric meter, wherever that cable is coming, that is known as the service mains. So hope these 3 points are clear. Now we see the classification of the distribution system. So a distribution system is classified on 3 different points. First of all, nature of current, whether it is an AC distribution system or a DC distribution system. Secondly, type of construction, whether it is an overhead distribution system or an underground distribution system. And the last type is the scheme of connection. So what is a scheme of connection? It is the type in which the distribution system is connected. So whether it is radial, ring main and interconnected system. Since we have discussed the first two types already in the previous lecture, in this lecture we'll concentrate on the scheme of connection, that is what is radial, ring main system and interconnected system. So let us see first the radial system. In this system, separate feeders radiate from a single substation and feed distributors at one end only. So if you see, the direction or the flow of current is only unidirectional. The main drawback of this system is that the end of the distributor nearest to the feeding point will be heavily loaded. The consumers are dependent on a single feeder and single distributor. Therefore, any fault on the feeder or distributor cuts off the supply to the consumer who are on the side of the fault away from the substation. The consumers at the distant end of the distributor would be subjected to serious voltage fluctuations when the load on the distributor changes. The only advantage of this system is it is the simplest distribution system and has the lowest initial cost. But due to the stated drawbacks, this system is generally not preferred. Therefore, we go for the second system, which is ring main system. In this system, the primaries of distribution transformer form a loop. So if you can see in this figure and in this figure, this is a primary of the distribution transformer forms a loop. The loop circuit starts from the substation bus bars, make a loop through the area to be served and returns to the substation. So in the figure you can see a single line diagram of a ring main system for AC distribution with substation supplies to the closed feeder. So if you see L M N O P Q R S, this is the closed loop which is formed over here. The distributors are tapped at different points, right? So at point O, you can see over here this one O M, right? Q. The feeders, the ring main system has the following advantages. There are less fluctuations at consumers terminals. The system is very reliable as each distributor is fed via two feeders. In the event of fault on any section of the feeder, the continuity of the supply is maintained. For example, suppose the fault occurs at point F as is shown over here, right? Then of section SLM of the feeder, then section SLM of the feeder can be isolated for the repairs and the same continuity of supply is maintained to all the consumers via the feeder SRQPONM, right? So that is about the ring main system. Now we go to the third type of system, which is the interconnected system. When the feeder ring is energized by two or more than two generating stations or substations, it is called interconnected system. So if you see in the figure, the single line diagram of the interconnected system is shown where the closed feeder ring, that is A, B, C, D, is supplied by two substations S1 and S2 at points D and C respectively. The interconnected system has the following advantages. It increases the service reliability. Any area fed from the generating station during peak load hours can be fed from the other generating station. This reduces the reserve power capacity and increases the efficiency of the system. So that's all for in this video. We'll cover the remaining topic in the next lecture. Thank you.